your Google Classroom, so be sure you're always checking there. Also, digitally, you may find that we have our wonderful resource here. So when you sign into Clever, you should have bookmarked this already. If not, there are more directions in your Google Classroom on how to get there to Clever. Hopefully you bookmark Clever. When you go into Clever and get into McGraw-Hill, that's our red app we'll be using. Your 7th grade should look like this purple thing here. And you can access these materials here as well. Okay? So today, right here, it says we're doing unit rates involving ratios of fractions. It's exactly what we did yesterday too. So we're gonna have to skip forward a little bit. Yesterday we left off, I believe, on page 6. Is that true? Yes. So we are going to start today with doing the check on the bottom of page 6. So I want you to try the check in your packet on the bottom of page 6. And I'm going to skip there in our resource digitally while you do that. The check on the bottom of page 6. Guys, do what you need to do to get the check done on the bottom of page 6. This was from example. Really, was it example? You probably need to go back. Oh, no, we're good. They gave us 4 methods that we can use, and we're trying to figure out what his average speed was in miles per hour. So again, we're on page 6 in our packet doing the check. Doug entered a canoe race. He paddled 5 miles in 2/3 hours. What is his average speed in miles per hour? You may use any one of the strategies that we learned yesterday. If you don't remember the strategies we learned yesterday, or you were not here, you're going to want to go back into that digital resource and fill up your packet and make sure you have those notes. Okay, so what kinds of strategies are we using? Are we getting anybody trying anything? Are you just staring at your packets? Okay, you gotta practice now. If you've had a hard time with your quiz, it's potentially because you didn't practice along with us. I should be doing this check on the bottom. So we know how long it took him in 2/3 of an hour. So if we wanted to draw a picture, we could. I kind of like that thing. That's not what I wanted. I didn't want a highlighter. Let me grab my pen here so we can annotate right on the screen for everyone to see. So if we do our, what they're calling a bar diagram, we know a whole hour has how many thirds in it? 3, right? So I'm gonna separate this into 3 pieces. So this 1/3 of an hour took so long. This 1/3 of an hour took so long. And this 1/3 of an hour took so long. So if we know that 2/3 took how long? 5 miles. how long did 1/3 take? 2.5. So you could say 2.5 or 2.5 for each one of these. 2.5 plus 2.5. So how am I going to figure out, now that I know how long each third is, what do I have to add to the 5 to get a whole hour? 2.5. I'm adding 2.5 to 5, right? To get 7.5 miles per hour. So hopefully you're able to write down some work and show a little work there on page 6. And would you stay there on page 6 with me for just a moment? Because I'm going to go ahead, and switch to our next resource, which I'm hoping is another, oh, no, we're not doing another example yet. So go ahead and flip over to find example 2 on page 7, or on page 7 in our packet. Page 7, it says Josiah can jog 5/6 of a mile in 15 minutes. Find his average speed in miles per hour. Well, what do you notice about both quantities of the rate? So this one is in miles per minute, and we have to find his average speed in miles per hour. So what did we say 15 minutes was? What part of an hour? How much is 15 minutes? A quarter. Excellent. So we're going to have to think about it as a quarter. So you know that 15 minutes, hey, look at that, is a quarter of an hour. So Josiah's rate is 5/6 mile per 1/4 hour. You need to find the unit rate, the number of miles he can jog per 1 hour. So they drew 2 bars to model the ratio 5/6 to 1/4. And they divided each bar into 4 sections because there are 4 sections of 1/4 in 1 hour. So this whole, so 1/4 plus 2/4 plus 3/4 plus 4/4 is a whole hour. You see where they're doing that? They have this all drawn out for you. So hopefully you may just follow along right now and you're with us. To find the unit rate, we first find the value of each section in the bar representing miles. Okay, so each one of these is 5/6, right? 5/6 plus 5/6 plus 5/6 plus 5/6. Or they're saying 4 times 5/6. So we can either add up our 6 or we can multiply by 4. So that tells us that the unit rate is what? What are we going to put here in this box in your packet? 3 and, it's telling it right here, 3 1/3 miles per hour. How did they get 3 1/3 from 26? Well, remember that fraction bar means divided by. 20 divided by 6 doesn't go in evenly, but that does give us a 3 because 3 times 6 is 18. 20 minus 18 is 2, so we have 2/6, which reduces to that 1/3. We can divide them both by 2. Remember how to simplify fractions? Remember how to change from an improper fraction to a mixed number? All of that is a pretty good review that we have to remember from 6th grade, right? Okay, remember if you're struggling and you need those review things from 6th grade, I have a whole YouTube 6th grade playlist. You can go through and get extra instruction on those topics as well. And that's in Google Classroom. All right, method 2. Remember, they're giving us lots of methods, not to confuse us, but to see which one makes the most sense to me, which one do I understand better. That's the one I'm going to stick to, okay? So method 2 is to use a double number line. So move through the slides to see how a double number line can be used to find the unit rate. So the top number represents the number of hours. The bottom number represents miles. So they're gonna, mark each one a quarter of a mile. They've done that for you as well. So they chose to do 4 of them, right? 0, 1/4, 2/4, 3/4, and 1. So it's separated. And each one is another 5/6. So they're adding on. So this becomes 10/6, and then 15/6, and then 26. Do you see that? And that 26, they are reducing or simplifying into a 3 and 1/3. Does that make sense? Do you see how that method is a little bit different, but of course it gives us the same answer if we do it properly. All right, using a ratio table, remember how we scale up. How do we get from 1/4 to 1? Well, we multiply by 4. So whatever we did to the top one to get the next one, we have to do to the bottom. When we multiply 5/6 by 4, we can rewrite it as 4/1. So we would have 5 times 4, which is 20, all over 6 times 1, which is 6. All right, so that one would be 20/6, or in other words, simplified to 3 and 1/3. And finally, method 4. All right, we call this a complex fraction because we have fractions within our fractions. Anytime our numerator and denominator, either one of those are fractions, we call it a complex fraction. What does the fraction bar mean? What operation is our fraction bar? Division, excellent. So this is really going to be read as 5/6 divided by 1/4. So they're going to take us through these steps again. So you're going to rewrite it as 5/6 divided by 1/4. Can we divide fractions? No, we have to take the multiplicative inverse. So we're keeping the first, changing the multiplication and flipping the second. You see that they did that on the next step. So they wrote it, the complex fraction, as a division problem, and then they're rewriting it as multiplication. They kept the first, they changed to multiplication. What was on the bottom went to the top. What was on the top went to the bottom. You see how they flipped that, Kaden? Focus with me. Now, they multiplied. They said 5 times 4 is 20, 6 times 1 is 6. They kept them in the numerator and the denominator, and then they must simplify. So the unit rate is, again, 3 and 1/3 miles per hour. Okay. So Josiah can jog 3 and 1/3 miles per hour. How could you word this problem using minutes instead of hours? Could we reword this problem using minutes? Maybe, right? We could find the number of miles per minute, or we could find the number of miles in 60 minutes. So if we were finding the number of miles in 60 minutes, we would expect the same, right? Because 60 minutes is an hour. But if we found the number of miles per 1 minute, it would be different, right? Because we would be dividing that by 60. You would not be able to run as many miles in a minute as you can an hour, right? All right, here is your check. It is on page 8 on the bottom there. A garden hose was left in a yard and spilled 7/8 gallons every 2/3 of a minute. Find the average number of gallons spilled per minute. So do you want to draw it out? Do you want to make the bar graph, the line graph? Do you want to divide? You have to pick one of those methods. You were given 4. Do you want to use a ratio table? I forgot about that one. So give it a second and try that out. Start by writing something down. You sitting there doing nothing is not helpful. Make sure you're doing it, right? All right, hopefully you're getting something written down. So what method would you like me to use in the show? What do you want me to use, Carter? The ratio table. All right, so I like the ratio table. Our ratio is 7/8, right? So you have gallons and minutes. So I know it's kind of a crude drawing, but my minutes is 2/3 of a minute here. So what do I have to multiply this by to get it to be 1 minute? What do I have to multiply? Ooh, that's a little tricky. What do I have to multiply 2/3 by? Do you guys remember reciprocals? When we multiply a fraction by its reciprocal, it equals 1. So what is the reciprocal of 2/3? Kaden, what's the reciprocal of 2/3? Flip it. What was on the bottom? Good, excellent. 3/2 now. So in order to get 1, we have to multiply by the reciprocal. So if I multiply this by 3/2, I also have to multiply this by what? 3/2. Now, isn't this the exact same thing as 7/8? The first divided by the second? Isn't that the same thing? So we're looking at ratio tables and we're looking at how to divide, because in order to figure out this one, we had to multiply by a reciprocal. So it's the same thing, especially when our both of our numerator and denominator are fractions. So we kept the first, we changed to multiplication, we flipped the second. So now we're multiplying straight across. What's 7 times 3? 21. And what is 8 times 2? 16. Now, if I'm changing to a mixed number, can I take more than one group of 16 from 21? I can? I cannot. If I take one group of 16 out, I'm subtracting 16. How many are left if I take a whole group of 16 out? 5. And I write that over my denominator. So 1 and 5 what? 16. Okay, so that is 1 5/16 gallons per minute. Interesting. Can you get this the other way? Of course. So if you drew out 8, it gets a little bit, I'm sorry, if you drew out thirds, right? 2/3. And you know that these 2/3 are 7/8. We have to divide that in 2. So this is really like 3.5/8 plus 3.5/8 plus another 3.5/8. It gets a little trickier when both our numerator and denominator, or both parts of our ratios, are fractions. I would say that this is on the trickier side, right? When both parts of our ratio are fractions. I would always recommend using your division method. The first divided by the second, because that's what we ultimately do with our ratio table too, right? Okay, questions here? All right, hold tight there for a second. I'm gonna see if there's another example for you to do next. Otherwise, I think we're gonna move on. Oh, all right, we're ready to apply. Fantastic. So we are on page 9. You guys are doing wonderfully well following along. Hopefully you are on page 9 on the top. This is very fancy. Do you see these friends kayaking here? Carolina and her friends are training separately for a kayaking competition. The average distance and time traveled by each is shown in the table. If the distance kayaked in the competition is 3 miles, predict who will win based on the rates shown. So we're going to predict how long it will take the winner to complete the race if their rate remains constant. So we know how long they've traveled and we know how long it's taken them thus far. And we're trying to see who is going to take the least amount of time. All right. So which method do you think is more advantageous to use when solving this problem? And maybe this alluded to this accidentally in our example just now. But when we have fractions and fractions for both parts of our rate, oftentimes division is going to be our best way to find our unit rate. All right. So you can see that it is asking you oh, no, we need to walk this through. Why didn't it walk us through the other one? Oh, you know what? I think maybe it wasn't loading. Do you think? Is that what's going on here? Oh, here we go. Here we go. All right, so here's our table. Here's first. Do you see where we are on your page now? Sorry, it was wonky. I guess it wanted me to scroll down. That's what those circles were meaning. I was like, all right, please stop the noise. Thank you. All right, make sure you understand exactly what question to answer or problem to solve. You may want to read the problem 3 times and discuss these questions with a partner. So the first time you read it, describe the context of the problem in your own words. So Carolina and her friends are training separately for a kayaking competition. The average distance and time traveled by each is shown in the table. If the distance kayaked in the competition is 3 miles, predict who will win based on the rates shown. So we're trying to find a rate. Predict how long it will take the winner to complete the race if their rate remains constant. So we're trying to figure out, what is this asking us, right? The second time, what mathematics do you see in the problem? Well, we see 3 miles, we see rate, we see table, we see average distance. We see time, we see if their rate remains constant. So there's a whole lot of math going on. Now, the third time, what are you wondering about? So Carolina and her friends are training separately for a kayaking competition. The average distance and time traveled by each is shown in the table. If the distance kayaked in the competition is 3 miles, predict who will win based on the rates shown. Predict how long it will take the winner to complete the race. So what are we being asked to find out? What is our task? We're trying to figure out how long it will take each of them to finish what? The kayaking race, right? And how long in distance is the kayaking race? It's 3 miles. So we know how long they've gone. Some of them will be easy because some of them have already gone a mile, right? We can just multiply that by 3. but others of them have only gone part of the mile. So we have to figure that out. All right. So how can you approach the task? They're giving you lots of ideas here. What strategies can you use? If we have a unit rate, if we know how long it takes them to do 1 mile, we could multiply it by 3, right? So we could find the unit rate or find how long it takes them to do 1 mile and multiply by 3. Then how do we kind of get our answer? Whoever takes the most time or the least time wins the race. So whoever takes the least time to kayak wins the race. So maybe we could just tell by the rate, which means whoever has the biggest rate or the lowest rate wins the race. The bigger the rate, the faster they're going, right? So whomever has the fastest or greatest rate wins. So those are a few strategies that we could use. We could find the unit and multiply by 3, and whoever has the smallest number would win. Or we could see who's going the fastest, because we're assuming that this rate is the same. So write one of those strategies down or get something down in your own words. All right. So hopefully that gave you time to get something down. What is your solution? So now we're going to use that strategy. Which person will win the race based on the rates shown? So if we're finding the rates, students lost. All right. If we're finding the rates, let's find the rates. We have to figure out miles per hour, right? So who's ever going the furthest fastest? So miles per hour. Remember, per we read as divided by. So miles per hour, we're saying 7/8 divided by 1/2. So 7/8 on your piece of paper there, you've got some space, right? So that's where you should be writing this on your packet, where it says number 3, what is your solution? So 7/8 divided by, this is going to give us per, and we want it by per hour. That's our rate. We want to see who's going the fastest. Divided by 1/2. Well, we know we can't divide fractions, so we have to take the multiplicative inverse. So we keep the first, we change to multiplication, and we flip the fraction. Now, if we haven't looked at cross canceling, I would love to do that because it helps keep our multiplication easier. If I can take out a factor of 2 from itself 1 time and 8 4 times, then it's a lot easier problem. I simply have 7/4. Now what I did is I divided the top and the bottom by 2. If you're not understanding that and you would prefer to say 7 times 2 and get 14, 14/8. Your 14/8, when you divided both by 2, would reduce to 7/4 as well. So Carolina's rate is 7/4 miles per hour, or you can look at it as how many groups of 4 can I take out of the 7? Just 1. And then if I take out a whole group of 4, that's 7 minus 4, which is 3, and I write that out of how many made a whole group, which is 4. So Carolina is 1 3/4 miles per hour. Leslie, we have 1 divided by 1/3. 1 divided by 1/3 is really 1 times 3/1. 3/1 is really 1 times 3. So her rate is 3 miles per hour. We have 1 3/4 and 3. Who's going to win between Carolina and Leslie? Leslie, right? She's going almost twice as fast as Carolina. Good job, Leslie. All right. Brian, 3/4 divided by 3/4. So I'm keeping the first, which they're the same, and then multiplying by the multiplicative inverse, or the reciprocal of the second. 4, good. Anytime we multiply by the reciprocal, we get 1. So who's losing between Carolina, Leslie, and Brian? Brian. He's going 3/4 miles per hour less per hour. And Javier, 1 divided by 2/3. So this is going to look an awful lot like this one, except we're going to take the first, change to multiplication, and then flip the fraction. So I have 1 times 3, which is 3, 1 times 2, which is 2. So I have 3 halves here, which is 1 and 1/2. So we have Carolina, Leslie, and Brian and Javier's rate. So who's going the fastest? Leslie. Excellent. So which person will win the race based on the rates shown? Who are we going to say there? Number 3, Leslie. How long will it take the winner to complete the race if the rate remains constant? How long is it going to take her, Leslie, to go 3 miles? Well, this is 3 miles per hour. So per 1 hour, she can go 3 miles. So how long is it going to take her to go 3 miles? 1 hour. 1 hour. This is 3 miles per hour, which means I can go 3 miles every 1 hour. So it's going to take her how long? 1 hour. Yep, because she can go do those 3 miles in 1 hour. All right. So which method is more advantageous to use when solving this problem? Well, we use division because it kept it clear cut. We're always taking the first times the flip version of the second, or the multiplicative version of the second, or the reciprocal of the second. I know that's a lot, and hopefully we can remember that. And finally, here is your check. I do believe this may be on page 10. It sure is. So turn to page 10, and here is your check for the day. I'm kind of thinking this is where we're going to be leaving off. So a walkathon was held at a local middle school. Remember how many times we read through the first applied problem? It takes a while to really figure out what we're doing, right, Carter? If you're over and fooling around, are you going to learn math today? No, you're not. You're more behind. That could be true. A walkathon was held at a middle school. The table gives the average distances and times for 4 walkers for certain periods of time. I only see 3 walkers. Okay. If the total distance of the route was 2 miles, who completed the route first? And how long did it take her to complete the route if she walked at a constant rate? So we've read it once. We're trying to figure out what they're asking us. We're trying to figure out what our context is. So let's read it again. Are you ready? A walkathon was held at a local middle school. The table gives the average distances and times for, I'm going to say 3 walkers. I'm thinking that's a misprint. For certain periods of the walkathon. If the total distance of the route was 2 miles, who completed the route first? How long did it take her to complete the route if she walked at a constant rate? So we're trying to find rate. Remember how we find a unit rate? We take the first divided by the second. That gives us distance per, what's time in this case? What's time in this case? Minutes. So be careful with your table and your labels. And then we're going to see who goes, we want to know the fastest or the slowest. So the fastest answers our first question, and how long that person took answers our second question, okay? Try this out and go. All right, Julian. Yeah, we're gonna go over this in just a couple minutes. I'm trying to figure out how to card. Okay, so you gotta start writing the problem down, right? If you don't know where to start, always start with writing down what you know. So I know we want the first divided by the second. So I'm writing 7/8 divided by 18. What is 18 as a fraction? How can I write 18 as a fraction? 18 over 1, yep. Any whole number we can write over 1. So then I'm really writing even 7/8, keeping the first, changing to what? Multiplication and flipping it. So what becomes on the top now, Kaden? What's on the top now if I flip it? 1. So the bottom goes to the top goes to the bottom. And now I have to multiply. If you need your multiplication table, use your multiplication table. 7 times 1 is 7. Who can look at their multiplication table for me and tell me what 8 times 18 is? 124? 124. All right. So 7 and 124. 7 and 124 miles per minute. So this girl still gotta go a lot more, right? She's only got 7 of the 124 parts of the mile per minute. So, well, that's not a very fast rate, but we'll see. We'll see. So this is Lakeisha. You need to do Baden. So Baden, 9/10 divided by 22. Remember, we can write 22 as a fraction out of 1. So 22 over 1. Again, you're keeping the first, changing the multiplication, flipping the fraction. That's what you need to do here. And then you need to do Madison. All right. Keep going. Do not give up. Get some of these done so that we can finish this up on Friday tomorrow. after we go over this check, you're gonna be spending the majority of the hour practicing. We have got lots to practice. You're gonna have to practice using your notes, practice going back and reviewing. Okay, what steps did they take on a similar problem? Now I can take those same steps on that problem, right? All right, you got another minute. I want you to keep trying and then I'll let you know when you can start putting your things away, which is not right now. You gotta try and figure out this problem first. And answer both questions.